students, in my last video we have learned the rules for naming the coordination compounds. Okay, today let us name some important coordination compounds according to the UPSC system. Yes, the first compound CuNH34SO4. Okay, yes, by naming a coordination compound, we know the positive part of the coordination compound is named first, then negative part. Here, the coordination entity is the positive part. Okay, coordination entity is the positive part and the counter ion is the negative part. Then this coordination entity is named first. Then the second rule, the name of coordination sphere. We know the ligands are named first, then central metal. Here NH3 acts as ligand. NH3 means amine. Its name is amine. If NH3 ammonia molecule acts as ligand, we know it is called amine. AMMINE. Then here 4 NH3 ligands are attached to the central metal. Then we have to use the prefix tetra to indicate the number of NH3 ligands. Then yes, ligands amine, tetra, amine, okay, copper, the central metal, copper, then yes, that indicates the oxidation number of the central metal in parenthesis. Yes, then oxidation number of the central metal. Yes, SO4 is a radical. Its charge is -2, NH3 is 0. The oxidation number of copper is taken as X. Then -2 plus 0 plus X equal to 0. X equal to +2. The oxidation number is +2. The oxidation number can be indicated using Roman numerals 2. Yes. Then the very important rule, the name of the coordination entity should be right in one word. Okay. Then there's a gap. Okay, between this positive part and the negative part. Then tetraamine copper 2. Then a gap. Then you please indicate the name of negative ion, that is SO2 minus, sulfate ion. It acts as counter ion, sulfate. Tetramine, copper 2, sulfate. Then the next compound, it is a neutral complex. Yes, here two different ligands are present, amine and chlorido. Okay, the ligands are named according to alphabetical order. Then amine comes first. 2 amine ligands attached to central atom platinum. Then to diamine, AMMINE. Then 2 Cl minus attached to central atom. Means 2 means dichlorido, Cl minus chlorido. The name of the anionic ligands ends in O. Okay, diamine, dichlorido, chlorido, diamine, dichlorido. Then mention, indicate the name of the central atom, platinum. Diamine, dichlorido, platinum. Okay, then oxidation number of the central atom, platinum. Yes, Cl minus 1, NH3 is 0. Platinum is taken as X. 2 into -1, -2 into -1, -2, plus 0, plus X equal to, the total charge is 0. Then X is equal to +2. Diamine, dichlorido, platinum 2. Yes, the next complex CO, NH3 5, BrSO4. Here, coordination entity acts as positive part. Yes, it is named first. Amine and bromido attached to central atom. Amine comes first in the alphabetical order. 5 amine. Then the prefix is penta. Pentaamine. Bromido. Pentamine. Bromido. The central metal cobalt. Pentamine, bromido, cobalt. The oxidation number of cobalt SO4 -2, Br -1, NH3 0, cobalt. The oxidation number of cobalt is taken as X. Then -2 plus -1 plus 0 plus X equal to 0. Total charge is 0. That is -3 plus X equal to 0. X equal to +3. +3 is the oxidation state of cobalt. Cobalt 3. Yes. Then a gap. Okay. Sulfate. Pentamine, bromido, cobalt 3. Sulfate. Then next K3, Fe, Cn6. Here counter ion act as positive part. Potassium act as positive part. Okay? Potassium. Then a gap. Then we can name the negative part. Here coordination entity act as negative part. Ligands are named first. Then Cn minus cyano, 6 Cn minus, then hexacyano. Fe. Its Latin name is ferrum. Already we studied the important rule. Okay. In the case of anionic complex, the coordination entity carries negative charge. The name of the central metal ends in Ate. Fe is Latin word. Ferrum, iron. Fe, ferrum. Then potassium, hexacyano, ferrate. The oxidation number, ferrate. Potassium, first group, +1, Fex, Cn -1. 6 into -1, -6, plus X, 3 into +1 equal to 0. That is -3 plus X equal to 0, X equal to +3, potassium hexacyano, ferrate 3. Yes. The next complex, CO, En twice, Cl2 plus, it is a complex ion, cationic complex. Yes. Here, two different ligands are present. En is the short form of ethyne 1,2-diamine. Then Cl minus, chlorido. Yes, then chlorido comes first in the alphabetical order. Then Cl minus is named first. Okay, then dichlorido. Chlorido. Yes. En is a complex ligand. In my last video, already we learned the important rule. If the ligand name includes ditri, tetra, etc., its number can be indicated using bis, tris, etc. Okay. Then actually it is not a diethane 1,2-diamine. Okay. Bis ethane 1,2-diamine. Bis. Okay. In the place of di, you have to indicate bis to indicate the number. Dichloridol. Bis. Ethine 1,2-diamine. Then central metal cobalt, its oxidation number, okay, Cl -1, En is a neutral ligand, cobalt X, then 2 into -1, 2 into -1, -2, plus 0 plus X equal to, total charge is +1, yes, then X equal to +1 plus, yes, plus 1 plus 2, 3. Cobalt 3, but it is a complex ion. Then you please write ion here. Okay, dichloridol, bis ethane 1,2-diamine, cobalt 3 ion. The next complex, CO, En thrice, 3 plus. En thrice. Okay, ethane 1,2-diamine. Okay, its name include di. Then in the place of tri, you have to indicate tris. Tris. Ethine 1,2-diamine. Okay, close the bracket. Then cobalt. Then oxidation number of cobalt, En 0. Cobalt X 0 plus 3 equal to plus 3. Okay, the value of X equal to 3. Tris ethane 1,2-diamine, cobalt 3. Yes, it is a complex ion. Then tris ethane 1,2-diamine, cobalt 3 ion. Okay, the next complex is NaAgCN2. Yes. Here counter ion, Na plus ion, act as positive part. It is named first sodium. Then a gap. Then here complex ion act as negative part. Okay, ligands are named first. Then Cn minus means cyano. 2Cn minus. Then we can write dicyano. Okay, here the complex species carries negative charge. Na plus AgCN2 minus, then the name of the central metal atom must be ends in Ag. The Latin word of Ag is argentum. Okay, sodium dicyano argentate. Argentate, the oxidation number of Ag, sodium plus 1, AgX, Cn minus 1. 2 into minus 1. Plus X plus 1 equal to 0, X equal to plus 3, sodium dicyano argentate 3. Okay, the next complex, CrH2O5, NO2Cl2. Here coordination NAT act as positive part. It is named first. Then H2O. Here two different ligands are present. Okay, H2O and NO2. H2O aqua, NO2 nitrito N. Okay, aqua is named first. What is okay? Then 5 H2O penta aqua. Then nitrito N. Okay, nitrito N, penta aqua, nitrito N. Then the name of the central metal chromium. Okay. The oxidation number of chromium is Cl minus 1, NO2 minus 1, H2O 0, chromium X. 2 into minus 1, 2 into minus 1. Minus 2 plus NO2 minus, NO2 is a radical, its charge is minus 1, H2O 0, plus X equal to 0, then X equal to plus 3, penta aqua nitrito, N, chromium 3, then negative part. Counter ion, Cl minus, chloride, penta aqua nitrito, N, chromium 3, then there should be a gap between this positive part and negative part. Chloride, Cl minus, chloride. If Cl minus was inside the bracket, it acts as ligand, chlorido. Outside the bracket, yes, Cl minus acts as ion, simple ion, okay, chloride. Okay, next NaCO4. It is a neutral complex. Neutral complex, its charge is 0. CO means what? CO, carbon monoxide. Carbon monoxide, carbonyl ligand. If CO acts as ligand, it is called carbonyl. Okay, neutral ligand, CO. Then oxidation number of equal also 0. 0 plus 0 equals 0. Yes, well then, what is name? Tetra carbonyl nickel 0. Tetracarbonyl nickel 0. And the last example, K3FeC2O4 thrice potassium act as positive part, potassium, then gap, then name the coordination deity, C2O4 2 minus act as ligand. C2O4 2 minus is oxalato ligand, oxalato. Okay, potassium. Okay, 3C2O4 2 minus attached to central atom Fe, then trioxalato. Here also complex species carries negative charge. Okay, then the name of the central metal, yes, ends in H. Potassium trioxalato, ferrate. Then its oxidation number, potassium plus 1, FeX. Okay, then 3 into plus 1 plus X plus 3 into minus 2 equal to 0. Plus 3 plus X plus minus 6 equal to 0. Then minus 3 plus X equal to 0. X equal to plus 3. Oxidation number of iron is plus 3. Potassium trioxalato, ferrate 3. Okay, students, goodbye, study well.